Bismillahirrahmanirrahim. The topic of my research paper is Algorithm of Optimized Selection Sort. In this research paper, we have described the optimized selection sort. We have some searching algorithm like binary search, index sequential search, merge sort, and many of other. So we have to describe the optimized selection sorting algorithm. In short, we have say the OSSA. So using this, we have saved the 50% of the operation time with almost 100% accuracy. This problem is ordering the list of items, have many solutions, and these algorithms are simple, spontaneous, and some are complex, but all of these are produce fast results. These algorithms perform well on the work. These are algorithms work on less number of elements, huge number of elements, floating point numbers, specific range. Some are lexicographical in order and some are in statistical order. The complexity of these algorithms are generally in big O of n notation, where O represents the complexity of algorithm and value n represents the size of algorithm. We have the both we have the two groups like big O of n square and big O of n log n. The big O of n square includes bubble sort, insertion sort, selection sort, and big O of n log of n includes heap sort, merge sort, and a quick sort. The essential task that is performed by the most computer, it is used to commonly in large variety of important applications. These are used in universities, banks, and many organizations. The hypothetical complexity of this algorithm is big O of n square. So these algorithms are used in smaller amount of data and produce faster results, quicker results, and these are also solved by complicated sorting algorithms. So we have described the analysis of optimized. First we described the analysis of old selection sort algorithm. The selection sort is very easy algorithm, understand by very easy and useful and not very difficult like bubble sort and other algorithms. If your data has small keys but large data area, the selection sort may be the quickest one to optimize the results. Though we have the different selection sort algorithms, the execution flow graph. If we start with the value of x is from 0 to n minus 1, if I is greater than 0, then algorithm is not running, then stop. If I is greater than 1, then we have the index of large values and assigning these values, and finally with the result of large is insert into the x of I index. So when we execute the individual statements, the values of execution time, we describe the symbol C1, C2 up to C8, and the instruction executed by CPU are we assign the values n minus 1 time. So if the value of C3, we have the summation where I is running from 1 to n minus 1, summation I plus 1, and then we divide this summation into summation I plus summation 1. The final result of C3 is C3n into n minus 1 over 2 plus C3 into n minus 1. Similarly, the value of C4 is C4n into n minus 1 over 2. The value of C5 is C5n into n minus 1 over 2 when the value is 1. Otherwise, it will be 0. So when we compute these values a, b, and c, we have three constants. The final result, the p of n, becomes the an square plus bn plus c. So here is the best case the complexity of execution time algorithm. It shows the lower bound of asymptotically denoted with omega. Therefore, the constant a, b, c at the lower terms of n and taking the dominant term, that is n square. Then the asymptotic running time of selection sort will be omega n square and will lie on the set of asymptotic function, that is big theta of n square. So the old selection sort will be P of n is equal to big theta of n square. And similarly, when we compute the burst time complexity after computing the values of a, b and c, if we compute the values, the value of a is equal to 3 by 2, the value of b is equal to 9 by 2, and c is equal to -5. So when we put these values in equation, so we have the Tn is equal to 3 by 2 n square plus 9 by 2 n -5. Here the value of a is equal to n square, the value of b is n, and c is constant. So if we put the value n is equal to 100, the final result will be 15,445. So when we analyze the optimized selection sort algorithm, we have the three main characteristics. The first, that is in place the algorithm, and second, where the stable algorithm, not unstable algorithm, the algorithm is stable, and the third is simple, while all algorithm of order big O of n square. So all these characteristics are in the optimized selection sort algorithm. So the optimized selection sort algorithm, the running time is almost similar to old selection sort, which is big O of n square. If we compute the execution of individual times, the C1, C2, C3 and are the same. If we compute the value of C4, here summation I plus 1, where I is running from 1 to n by 2. When we divide this summation into I plus summation 1, the final result of C4 is C4 n by 2 into n by 2 plus 1 by 2 plus C4 n by 2. So if we compute the value of C5, the C5 n square by 8 plus C5 n by 4. Similarly, the value of C6, C7, C8 are the same value like C8 n by square by C8 n square by 8 plus C8 n by 4. So the instruction enclosed in this algorithm with almost 1% execution, if these statements are if statement, will execute. So we considering the total execution statement in case of either true or false logical conditions. So the best case time complexity is similar to the old selection sort, like a n square plus b n plus c. Here is the best case similar to old selection sort, omega and n square, then the omega n square, and finally the result will be theta n square. So the old optimized selection sort, the running time is theta n square. Similarly, the value of if we compute the value of worst case time complexity, the value of a, b, c computed, the value of a is equal to 5 by 8, the value of b is equal to 25 by 4, and the value of c is equal to 2. When these values are put in the equation, and we assign the value of n is equal to 100, the final result will be 6,877. So when we compare the old selection sort and optimized selection sort algorithm, if we give the value of n is equal to 50, the percentage improvement in is 52.7%, and if we give the value of n is equal to 100, is the percentage improvement is 55.5%, and we give the value of n is equal to 150, 200, then 250, then 300, then 350, then 400, then 450, and finally the value of n is equal to 500. The percentage improvement is increasingly bigger than the previous, then the final percentage improvement when the value of n is equal to 500, the percentage improvement is 57.8%. If we see the graph in the slides, the increase in number of data, when we increase the number of data and elements, the optimized selection sort takes less time as compared to old selection sort. It will be true for any number of data. So finally we conclude that the optimized selection sort take less time than old selection sort. So the logic of optimized selection sort based on old selection sort algorithm. The main difference in old selection sort and optimized selection sort is that the former sorts the data from one end, that is from largest element of array to smallest element of the array, or from smallest element of array to the largest element of array from the both the locations. And when we sort the second iteration, it sorts the second largest and second smallest element from the remaining array data and places those in their appropriate locations in the array. Similarly, it sorts the rest of data elements and put those in proper positions. The optimized selection sort the data in the half iteration as compared to old selection sort. The improvement is also of the order n square. So that's all. This is the whole scenario, the whole presentation of the optimized selection sort algorithm. We describe in this presentation the methodology or the conclusion or the body of this research paper, how this research paper is asking to us. So we have hope I will the way of my presentation is understand easily to you. So remember me in prayers. Thank you and Allah Hafiz.